Okay, so this is from the 2000 Physics B exam. This time we have 3 blocks connected to each other, and we have 2 different ropes. So blocks M1 and M2 are connected to each other, and then M2 and M are connected to each other. We're told some information about the friction, that the friction force on block 1 is F and is 2F on block 2. And block 1 and 2 are moving with a constant velocity down the plane. That's some very useful information. Okay, so I'm going to label this T1, and I'm going to label this T2 for me. And so I'm looking at the forces acting on M1. So we're going to have T1 up the plane. Okay, and now the velocity is down the ramp. Friction is present. Friction will be in the same direction as our tension. Okay, then we'll have our normal force for block 1, and then we will have M1G. Okay, those are all the forces acting on block M1. Okay, so part B, this could be a long one. So for part B, we can only use these variables. This is common. We need to be comfortable with that. Determine the coefficient of kinetic friction between the inclined plane and block 1. Okay, well, let's write Newton's second law. So for block 1, we have normal force minus mg cosine theta is equal to 0. So normal force is equal to mg cosine theta. And in the x direction, we have tension plus our friction force, okay, which I could rewrite friction as mu k times n, and it's mg sine theta, and it's equal to 0 because we are in dynamic equilibrium, constant speed, dynamic equilibrium. Okay, so well, what else? Determine the coefficient of friction between the plane and block 1. So we'll actually be coming back to these equations here, but they told us to let the coefficient of friction force equal F, and we know that's equal to mu k times n. So all we need to solve for mu k is we have that friction force F, and now we just need the normal force, which is mg cosine theta. So it's just F over mg cosine theta. Okay. We are definitely coming back to those Newton's second law equations. Okay. All right. Alright, sorry, it's a little bit cut off, but C says determine the value of the mass, m, that allows blocks 1 and 2 to move with a constant velocity down the plane. Okay. Alright. So, let's consider m. forces here are pretty easy. Okay, according to my definition, this is T2 minus mg is equal to 0. So T2 is equal to mg. Okay, now we cannot use capital M in our equations, and we cannot use T. Okay, let's look at block 2. The force. Let's look at our forces in the x direction. We have T2 to the right. And we have T1 pulling it down. Okay. And since M2 is moving downwards, friction force is actually up, so the friction force is actually positive. And we were told that it was equal to 2F. Okay. And then we have minus M2 G sine theta. And all that's equal to 0. So holy moly, there's a lot going on in that equation. Okay. Alright, so we can use F to describe things in terms of friction. We don't need to write things with the coefficient of friction, so we should keep all of our frictions in terms of F or 2F. Okay. So I'm going to rewrite this again. It's T2 plus F minus M1G theta equal to 0. So I can use, sorry, it's T1. This is T1. So I can use this equation to solve for T1. Okay, so what I'm going to do is I'm going to take this and I'm going to plug it into here, and then I'm going to take this and plug it into there. Holy smokes, we can do it though. Okay, so we have capital M, G. Going back, now we have minus T1. T1 is equal to M1G sine theta minus F. Then we have plus 2F minus M2 G sine theta is equal to 0. Alright, but we're not done yet. Let's go back here. I did this a little too quickly. Okay, whenever you substitute in, you should substitute this in with parentheses. So for T1, all of this stuff is in parentheses. So what does that mean? Okay, don't rush it. That means this is actually minus M1 G sine theta. And then I have to distribute this minus sign. So right here, this will become plus F. Plus 2F minus M2 G sine theta. Okay, so look, this will combine to be 3F. So capital MG minus M1G sine theta. Okay, and we are solving for this guy. So we basically want everything else to the right-hand side. Okay. So, oops. M1 G sine theta plus M2 G sine theta minus 3F. So now I get to divide by G. Okay, so we get M is equal to, and I'm going to pull out G sine theta because it looks really tacky. M1 plus M2 minus 3F. And then we have this over G, and this is also over G. So in order to simplify this as best you can, you get minus 3F over G. So that is the value of M, which is the big block here, that would allow the blocks 1 and 2 to move with a constant velocity down the plane. Okay, so up until this point it's been constant velocity, but now if we look at part D, part D says that the string between blocks 1 and 2 is now cut. Okay, so there's no longer a string there. And determine the acceleration of block 1 while it is on the inclined plane. Well, this is really good news because there's no longer any tension. Okay, so it's basically just rolling down the inclined plane, or sliding down the inclined plane. Let's look at our forces in the x direction now. So now it is just friction, F minus M1 G sine theta. Let me set that equal to minus M1A. It is accelerating to the left down the ramp. So we are solving for A. So I'm just going to move MA to the left hand side and move M1 G sine theta to the right. Okay, you don't really have to do that. I just wanted to. But it does help me get rid of that negative sign for A, which is nice. And now all I really need to do is to divide by M1. So when I divide by M1, I get A is equal to M1 G sine theta over M1 minus F over M1. So A is equal to G sine theta minus F over M1. And this part should look really familiar. Okay, if there was no friction, it would just be G sine theta. So analytically, this part is because of friction. And think about it. What is acceleration is equal to F net over M, right? What is the net force acting on the block? Well, the net force, well, it's the x component of gravity minus the weight, and that's really what we just did here. So that is our final answer, and this is the solution to the 2000 B2 question. And I hope this helped you very much. Bye bye.